Can you see my slides okay, guys?
Yes, Professor.
Good, thank you. Now, good evening, everyone. I hope you are all doing okay, safe and healthy wherever you are. It is my pleasure to be here, to be part of the Nano-PAMS project. And I'm also hoping that you are as excited as I am. I'm also excited to be part of Nano-PAMS program because this is also part of my research and experience with regard to digital innovation. And since we are doing a kind of online learning, problems can come up suddenly. So if you cannot hear my voice, or if you if you cannot hear me clearly, then please do let me know. Don't be hesitate to interrupt. Don't be hesitate to ask anything. Okay. Now, this is the contents that I want to share with you in this session. First of all, I would like to give you a kind of introduction, and then I will explain the structure of Module 2 regarding digital strategy. And then I'll give you some of stories to give you a kind of background why digital strategy is very important, and why does it matters, and how it differs compared to non-digital strategy. And then we will look into the definition of digital innovation. We will discuss some of the fundamental assumptions and fundamental properties that distinguish digital innovation and non-digital innovation. And then we will move on to convergence and generativity, which is pretty much part of the digital innovation. And we will look into 3 important consequences of convergence and generativity. And we will conclude by giving you a kind of key takeaways on why this is important and how does it relates to your interest in digital strategy or in AI, or probably you have a kind of career prospects in the future in this particular field. Now, because this is the first time we met, so let me briefly introduce myself. My name is Novi Iman. I am from the business at Universitas Gadjah Mada in Indonesia. So I got my bachelor degree from Universitas Gadjah Mada, but then I did my master study at the University of Manchester in the UK. And then I worked for a couple of years in Jakarta, the capital city of Indonesia, for a couple of years. And then after that, I come back to the UK to do my PhD at the London School of Economics and Political Science. My research area is pretty much about innovation, about dynamic strategy, about how firms develop their innovativeness, about especially in the digital economy like what we are experiencing today. And I am also have a kind of interest in recent technological innovation like fintech and then blockchain and digital platform and things like that. My email address is novi.iman@ugm.ac.id, so feel free to if you have any question or things like that, please feel free to email me. Now, before we move on to the content of my presentation for this session, let me briefly explain the structure of this second module. So today we will talk about understanding digital innovation. So the central question is how does digital innovation differ from traditional or from non-digital innovation? Because the way we develop innovation traditionally versus the way we develop innovation in terms of digital world, in terms of digital economy is quite different. So that's why it is very important for us to learn about the nature of digital innovation in this first session. And then next Wednesday, we will talk about platformification in business and industries. So one of the consequences of digital innovation is what we call platformification. So companies are becoming a platform instead of developing products. We will talk about it later on, but essentially companies are today are preferring to develop their own digital platform instead of developing their own products. So we will, in this session, we will discuss how digital innovation changed the structure of these industries. So what are the consequences? What we have to do with it? How do we compete with other platforms and things like that? And then next Monday, we will talk about network externalities and standard in digital innovation. This is probably quite confusing for you because network externalities is very common in economics, but it also happens in the digital world, in the digital economy. Essentially, we will discuss about how new innovation related to past path dependence trajectories and current circumstances. So you cannot just develop your own product or your own services and then launch to the market and expecting something that this is going to be successful. No, it's not like that. You have to think about past path dependencies. You have to think about current circumstances, and the way in which we discuss about path dependencies and current circumstances is through network externalities and standard. And then next Wednesday, we will talk about strategies for adoption of innovation. So the central question for this session is, what does it take to scale up innovation in the market? Because developing new product, developing new service, creating something is one thing. But after that, you have to take them to the market. You have to convince other people to use your product or to use your service, and that's to be honest, there is something that is quite difficult compared to product development or service development itself. So I think it's important for us to learn some strategies and learn some cases about adoptions of innovation. So basically, that's all the course materials that we will discuss in module 2. If you have any questions, or do you think this is too much, or maybe you want to add something, please go ahead. Or if you have any question or something like that, please. No questions? Anything? Is quite clear and straightforward for you. So as I said before, in this session, we will discuss the way in which we understand digital innovation, and then next Wednesday, we will talk about platformification in business and industries. Then next week, we will talk about network externalities and standard in digital innovation, and next Wednesday, we will talk about strategies for adoption of innovation. So all of this is under the overarching theme of digital strategy. Now, does anyone knows this paper? No? Anyone anyone want to comment on this paper? Briefly, you can see the title, you can see the author, you can read the abstract. Anyone? Anyone knows about this paper? No one? Come on, say something.
I might assume that we do not have the link to this paper uploaded in our smart system.
No, it's not from our LMS. But can you recognize something from the paper?
Is it about the search engine, Google?
Yeah. Yes. Anything else? So this is actually a paper written by Sergey Brin and Larry Page back in 1998, when both of them are PhD students at Stanford University. So in this paper, they describe the way in which they develop a kind of new search engine, which is better or more accurate compared to the existing search engine at that time, which is Yahoo and Alta Vista. You can access the paper if you are interested, or if you are curious about this, you can access the paper in this URL. I'll give you the slide later on. But from there, they established the company, they established Google, and then they went public in 2004, August 2004. So from 1998, the conceptualization of the search engine, the conceptualization of algorithm and things like that, back in 1998 to going public in 2004. This is very, very fast. If you are in traditional industries, if you are in non-digital business sectors, you will need maybe 10 years, 20 years, 30 years, or more than that to go public. But in digital business, you can go public in less than 10 years, and it is quite common. Okay, and we know now Google is becoming one of the most valuable company, not only in the US but in the world. So I'll give you another background story. This graph was taken from a book entitled "The End of Accounting and the Path Forward for Investors and Managers." The book was published in 2016. So this graph is very interesting in a way that if you can see the blue chart, it represents the accounting information relevance towards the price in the stock market or market capitalization of the company. So from year to year, from 1950s to 2000, the graph is slowly decreasing. The relevance of accounting information is no longer relevant nowadays, because companies are no longer relied on fixed asset, no longer relied on. If you studied accounting, you know how to value a company. You have to count how much the company has in terms of assets, in terms of maybe they have land, buildings, factories, cars, machineries, and things like that. But nowadays, those kind of information are no longer relevant. And on the other hand, if you see the chart with the orange color here, you can see that R&D and SGA is general expense and administrative expenses as percentage of sales. So usually R&D and SG&A represent the intangibles of the company. So you can see that the intangibles of the company is increasing from year to year. But the relevance of traditional accounting information, like what I said before, fixed asset, buildings, cars, machinery, factories, and things like that are becoming no longer relevant. So this chart is implying that we can consider technology, we can consider, for example, in the case of Google, we can consider algorithm, we can consider our AI, maybe our proprietary technology and things like that as one of our assets, as one of our valuable asset or valuable properties. Okay, so and this is becoming much more relevant today, because if you take a look at the financial statement of technological companies like Google, Apple, Facebook, and things like that, they don't have pretty much, they don't have a fixed asset in their book valuation. On the other hand, they have lots of intangibles there, and it is one of the things that makes them valuable in the market. Now, one more thing. Please take a look at the following map. Do you recognize something here? Anyone want to comment on this?
Maybe it is the proportion of the content in some social media, or like what the people search for on the internet.
Yeah, yes, correct. Thank you. So this is a visualization of online communities across the world, but not today. It was back in 2007. You can see there is MySpace over here, and then Friendster. Anyone remember Friendster? We can find YouTube over here, and then Flickr, Last.fm, Wikipedia, AOL, Yahoo, Windows Live, Orkut, Facebook, and so on and so forth. But if we ask the artist Randall Munro to draw a map like this based on 2020's data, the map will be very, very different, because many players who were market leaders at that time were now no longer exist. On the other hand, companies like probably Facebook, which is very small back in 2007, now pretty networking in 2020s. So what I would like to emphasize here is that changes in terms of digital technology, in terms of digital business, is happening very, very fast. It is not like what happens in traditional business. It is not like what happened in non-digital business. In non-digital business, mergers, acquisition can happen maybe once in 5 years, once in 10 years, and so on and so forth. But in terms of digital world, in terms of digital innovation or digital technology, changes can happen anytime. Changes can happen overnight. So we really have to be very, very careful about this. On the one hand, you can utilize technology, you can utilize digital innovation to increase your market value. But on the other hand, you have to be very careful because changes are happening very fast. If you are not very careful, then your competitors will take over very quickly. So that's why digital strategy or digital business is very different compared to non-digital business or non-digital industries. Okay, that's just the background for the topic, and now let's move on to the next slide. Okay, this was a book written by Austrian economist. I'm sure probably some of you are familiar with his name, Joseph Alois Schumpeter. He wrote a book entitled Capitalism, Socialism, and Democracy back in 1934, I think. And he mentioned something which is very, very famous, even nowadays in 2020s. He said that innovation is a kind of creative destruction. Why he called innovation as creative destruction? Because innovation would destroy existing technologies, because innovation would destroy existing methods, existing procedures, existing paradigms, existing techniques, and so on and so forth, with newer and more efficient products. So if we come back to the previous slide, you can see that many of those companies, many of those products, or many of those services were now being replaced by something which is newer and also much more efficient. So that's why we see lots of discontinuity. We see lots of uncertainty in terms of digital business. We were moving from telephone line to optical networks to wireless internet connection to digital platforms. We see lots of mergers, acquisition, investment, and disinvestment happens everywhere. And we also see lots of social and political restructuring as part of innovation as creative destruction. So in this case, essentially, you have to essentially, Schumpeter want to say something like, you have to sacrifice your past. We can no longer rely on what happens in the past. Instead, we have to do something to get something better in the future. Now, in terms of digital market restructuring, we see lots of changes here. We see lots of industrial restructuring. Many companies emerge, many companies establishing a kind of alliances. They come up together to develop new innovations, or maybe at one time they are cooperating between themselves, but in some other times they are becoming competitors. And then we see lots of deregulation. We see the collapse of natural monopoly. We see lots of competitive entry and repricing, especially with the case of Uber, Airbnb, and other sharing economy initiatives like that. We see lots of newly competitive positioning. We see lots of new competitors coming into the market. They offer something through disruptive innovation, and they change our habits of consuming something. They take over the market that was previously dominated by incumbents, and so on and so forth. And then we see lots of technological assumptions, digital technology. We are now moving to wide bandwidth technology. We are now moving towards digital platforms. And we see lots of business ecosystem. I will talk about this in the next slides regarding ecosystem. But essentially, in the digital market, in the digital industries, you cannot survive alone. You have to establish, you have to build your ecosystem, you have to build your network, you have to act in unison and share your capabilities to others. Now, How do we define digital innovation? This is probably quite technical or quite complicated, but bear with me. Digital innovation is actually the creation of and consequent change in market offerings, business process, or business models that result from the use of digital technology. So anything that you develop, anything that you create, anything that any changes that happens in the market because of the use of digital technology can be classified as digital innovation. So because of this, we will include a range of innovation outcomes like new products, new services, new platforms, new user interface, and things like that. We will include lots of digital tools, lots of digital infrastructure that makes innovation possible, like 3D printing, big data, machine learning, artificial intelligence, and things like that. And then another thing that we have to remember is that the outcomes may be diffuse, may be assimilated or adapted to specific use contexts, such as typically experienced with digital platforms. Again, I will explain a little bit about digital platforms later on. And I will emphasize why digital platforms is now becoming very important and relevant. But essentially, this is the definition, the main definition or the basic definition of digital innovation. Anything in relation to the creation of and consequence change in market offerings, business process, or business models that result from the use of digital technology can be classified as digital innovation. Okay. Now, the problem is digital innovation is very, very different compared to traditional or non-traditional or non-digital innovation. Why? At least we have three fundamental assumptions. When we are talking about traditional innovation, usually innovation is well-bounded. So it is located in one place at one time, and it usually focuses on fixed products. With digital technology, with digital innovation, it's not like that. In traditional innovation or non-digital innovation, the nature of innovation agency is centralized. So usually one company doing everything, one company assemble their kind of R&D teams and then put them all together in one place to develop one products and so on and so forth. But today, digital innovation is completely different. And then the third assumption is that in traditional innovation, usually innovation process and outcomes are distinctly different. So you know what is the input, you know what is the process, and you know what is the outcome. But with digital innovation, it is not that clear. It is sometimes it can be quite difficult for us to define which one is the input, which one is the process, which one is the outcomes. Okay, so these are the three fundamental assumptions of traditional innovation, which is that no longer relevant, no longer true for digital innovation. And we will talk about that one by one. But before that, do you have any question? Or maybe I talk too fast or I talk too much. You want to repeat some part of my explanation, or maybe do you have anything you want to say or any question do you want to ask regarding this topic?
So could you please repeat? Can you hear me?
Yeah.
I'm sorry. Could you please repeat how old fundamental assumptions like transferred to something new, like, because I have very unstable internet connection, I couldn't hear the last part well.
Okay, the last part here. Okay, traditionally, in non-digital innovation, you can see very clear what is your input, what is your process, what is your output, or what is your outcomes. But with digital innovation, the process is not that linear. The process is not that clear. You cannot distinguish what is your input, what is your process, and what is your outcomes. Don't worry about that. If you are still confused or things like that, we will describe those three assumptions one by one. Okay, the first assumption. The first assumption says that innovation is a well-bounded phenomenon focused on fixed products. But with digital innovation, this is not true. This is not correct. Why? Because most digital designs remain somewhat incomplete. So there will always be a kind of iteration, revision, updates, and things like that that makes the products or the services is always in a state of flux. And because of that, we are facing with an unprecedented level of unpredictability and dynamism. Okay, another consequences is that the boundaries have become more porous and fluid. Innovation process and innovation outcomes have become less bounded. It is no longer located in one place at one time. It can be very fluid. It can be very dynamic, and it makes us quite difficult to define what is the start, what is the end. And sometimes the innovation process itself is not linear. So it's not like A, B, C, D, E, and things like that, but it can be like A and then moving to C and then coming back to B and then jump to K or M and then coming back to F and things like that. So it is completely dynamic, it is completely non-linear, and it tends to be very, very exponential. That's why we need a kind of new success criteria and new underlying factors that distinguish digital innovation compared to non-digital innovation or traditional innovation. If you are confused about this, let me give you a kind of simple illustration. So on the left-hand side, there is the interface of Google search engine back in 1998. On the right-hand side, there is the interface of Google search engine in 2020s. But the problem is, can you say that the picture on the left-hand side is the start and the picture on the right-hand side is the end? No, it is not clear. It is not as straightforward as that. Because even today, even tonight, Google is continuously revising their product. Maybe they change their algorithm, maybe they change their interface, maybe they will change the logo or things like that. So it is not as clear as, for example, if you are making a cake, you know what is the input, you know what is the raw material, you know that you have to you need a flour, you need eggs, you need a milk, you need a chocolate and things like that, and you put all of them together, bake them together to have your intended cupcakes like that. So the start and the end is very clear. The beginning and the end product or the final product is very clear. But with digital product, with digital innovation, it is not as clear as that. So in the picture on the left-hand side here, we can say that this is probably the beginning of Google. We cannot say that this is the final product, because even today, even tonight, maybe Google is still revising their algorithm. They're still revising their interface. Maybe they change the logo, maybe they improve their programming language, and so on and so forth. So that's why the first assumption is no longer relevant. The first assumption that says that innovation is well-bounded phenomenon focused on fixed product is no longer relevant for digital innovation. Now, the second assumption. The second assumption says that the nature of innovation agency is centralized in one place at one time.
Đầu tiên thì đây là anh Cao
Okay.
Khánh là trước là cái mục đích của cái dịch thuật thuật về mặt có thể coi như là team management nôm na kiểu là việc quản
Do you
trị
want to say something or do you want to ask something? Otherwise, could you please mute your microphone unless you want to say something?
Về kỹ năng giảng dạy thì nghĩa là mục đích của hôm nay là cùng nhau thống nhất ra được xem là trên cái outline mà đã soạn thì mình sẽ bớt gì và sẽ
Okay, if you want to say something, please unmute yourself. But if you don't want to say something, please mute yourself so that we can still focus on this topic. Okay, let's come back to the second assumption. The second assumption says that the nature of innovation agency is centralized, but in reality, it is not like that because we are now moving toward distributed innovation. We are now moving toward open innovation and network-centric innovation. Okay, because of that, we will have lots of different actors. We will invite lots of different firms, different organizations, different parties, with obviously each of them will have different goals, different motives, different interests, and so on and so forth. So that way, those kind of distributed innovation can they can opt in, they can opt out anytime they want, anytime they feel that the cooperation is no longer relevant, anytime they feel that their goals has changed, or maybe they need new competencies and things like that. So easy come and easy go. And one more thing is that digital platforms, again, digital platforms and open standards is very important here because we want to work together. We want to work as a collective innovation agent. So that's why we will need a digital platform and open standards. Otherwise, we cannot collaborate with each other. So let me show you. This is the simplified version of Apple's business ecosystem. Okay, we know that Apple is technology company. They are a kind of computer manufacturing companies. They produce. They also producing software. They also producing iPhone and digital platforms. And you can see here, Apple is working together with Foxconn, with AMD, with Intel, with NVIDIA, Samsung, ARM, LG, and so on and so forth. This is very clear. This is very straightforward because they are technological company and they are manufacturing their own products or their own computers. But on the right-hand side, Apple is also working together with media companies like Capcom, and then Buena Vista International, EMI, Sony, Sega, and so on and so forth. Why? Because Apple wants to offer something in relation to multimedia, in relation to games or entertainment into their products. And then they are also working together with developer. They are also working together with Facebook and Twitter. And then they are also working together with QLogic and Belkin, which is a little bit too distant compared to the core competencies of Apple. And then they are working together with Microsoft and Google. This is quite interesting because at one point, Microsoft and Google are the competitor of Apple, but at some other point they are working together. Why? Probably because Apple has to take into account Microsoft product like Microsoft Office, and also Google products like Google Chrome and things like that. And Apple is also working together with universities like MIT, for Humboldt universities, and so on and so forth. So as you can see, the ecosystem of companies in digital industries or in digital sectors is quite complicated. So it is not as simple as the ecosystem or the network of companies who are operating in non-digital world or non-digital sectors. With if you are doing business in digital ecosystem, or if you are doing business in digital industries, obviously you will work with many different parties, and sometimes those parties are will be very different compared to your main business. Now, the third assumption says that innovation process and outcomes are distinctly different phenomenon. But this is not true, because dependencies between innovation process and innovation outcomes are very complex and very dynamic. So those kind of complexities, those kind of dynamics will generate multiple waves of innovation. So one companies are developing something, and then another companies are developing something else based on this something. And then another companies will develop another product based on this product, based on this innovation. And it goes on and on and on and on like that. And that way, innovation process and outcomes are shaping and being shaped by the other. So that's why it is important for us to learn about. If you still remember, in the third session, we will talk about network externalities and standard in digital innovation. Why? Because one of the things that we have to take into account is that innovation process are shaping and being shaped by the other. So you cannot just develop something on your own and then launch it to the market and expecting something that it is going to be successful. It is not like that. Okay. So this is an example of what I call waves of multiple innovation. So on the left-hand side, does anyone knows what is this?
Some player, very old.
Yeah, it's a kind of MP3 player, but it can be used as a kind of recording. So you can record, if you want to say something, you can record with this device and then plug into your computers and copy the files and so on and so forth. But then from this kind of innovation, which looks ugly probably, it influenced or it encouraged other companies, which is Apple, to develop better MP3 player. So Apple is not the first manufacturer who developed music players, portable music players. It was already being developed by some other companies many years before, but somehow Apple got it right, and then they launched to the market and very successful in early 2000s. And then if you can see on the right hand side, they take it further. They develop iPod to become iPod iPod Nano, which is smaller, with better capacity, with better quality of audio, with more music or more songs that you can listen to, and so on and so forth. So again, innovation is no longer fixed, is no longer centralized, and it is also quite difficult for us to categorize or to distinguish or to differentiate what is the beginning and what is the end, what is the input and what is the outcomes. Any questions before we move on? No? Questions? Anything? So far, so good? You looks confused? Okay, now let's move on to let's come back to the digital innovation. Okay, so what makes digital innovation quite complicated is that we have to deal with two different things. On one hand, you have to deal with physical materiality, which is the artifact, which is the product or the item that can be touched, that can be seen, that can be changed, and so on and so forth. But on the other hand, you also have to deal with digital materiality, which is the software, which is the application that being put into the artifact, into the physical material. And by combining those two all together, you can manipulate your digital representation. Okay? I know you're a little bit confused, but bear with me. I'll give you an example. So essentially, the fundamental properties of digital technology is one, reprogrammability, what we call reprogrammability, and secondly is what we call data homogenization. These two are the fundamental properties of digital technology. One is reprogrammability, and second is data homogenization. Okay. So this is what we call reprogrammability. So basically, every tools, every device that you have, your mobile phone, your computers, your laptops, your iPad, anything, basically it follows a von Neumann basic structure. Von Neumann is a mathematician, but he gave a kind of foundation for developing a modern computer. So von Neumann architecture basically consists of three different parts. The first one is your input, and then the main part is called central processing unit. And then the third part is called output. So your computer, for example, will have an input like your keyboard, your mouse, your microphone, your camera, and things like that. And it will have a central processing unit, your processor, your memory, your hard drives, and then it will also have output device, your screen, your monitors, your speakers, and things like that. So every digital technology is basically following von Neumann architecture. It will have has an input device. It will have central processing unit and memory unit to store your processing data, and then it will send the output to the output device like your monitor, your screen, and so on and so forth. So essentially, every digital technology will follow this kind of structure. This is what we call reprogrammability, okay? Because everything is following von Neumann architecture, so essentially we can reprogram everything because every device, every tools is following von Neumann architecture. And then secondly, what we call data homogenization. So with data homogenization, we convert every data into binary codes. So for example, if you want to write 66, then the computer will convert it into 0, 1, 0, 0, 0, 0, 0, 1, and 0. If you want to write, for example, if you want to write Q, then the computer will convert your input into 0, 1, 0, 1, 0, 0, 0, 1, and so on and so forth. Now, what about image? What about pictures? What about videos? The same thing happened here. So basically, if you are dealing with pictures or videos and things like that, basically it consists of million or billion pixels. It depends on the resolution. But if you break it down into very, very small details, it will look like this. and then the computer will convert it into halftone image. They will generate a threshold matrix, and we can come up with binary code, 01010001 and things like that. So by combining binary code and von Neumann architecture, theoretically, you can do anything. You can make anything, you can develop anything. It just really depends on the processing power that you have. If your computer is capable of doing that kind of manipulation or that kind of programming capacities and things like that, then so be it. Okay, so this is the nature of digital technology. Everything is following von Neumann architecture, and everything is being converted into binary codes, 01000101, and so on and so forth. So by combining those binary codes into von Neumann architecture, you can do anything you want. It just really depends on the processing power or the capacity that you have on your computers. Okay, if you want to type something, if you want to write something, then maybe you don't need that much processing power. But if you want to work on something like a complex computational method, or maybe you want to develop your own cryptocurrencies or your own blockchain, then maybe you will need a higher processing power. Okay, any questions? You look so confused. No questions? So again, please keep this in mind. This is the fundamental properties of digital technology, reprogrammability, and data homogenization. So anything in this world can be converted into binary code. Your voice, your picture, your text, anything, it can be converted into binary codes. And once your input is becoming binary codes, you can put it into your machine, which follows a von Neumann architecture. And by doing so, you can manipulate everything. You can develop everything. Theoretically, it is unlimited. It just depends on your creativity. It just depends on your computing power and your processing capacity. That's why maybe some of you ever heard about technology affordance. Technology affordance is basically technology is becoming much more affordable, much more accessible, and also cheaper. We can do a lot more with technology, with digital technology. That's what we call as technology affordance. So for example, back in 1990s, if I want to make a phone call abroad, I have to put my phone, and then I have to dial a special number. I have to ask my operator to forward my call to someone on the other countries. But with new technology like what we have now, if I want to make a phone call with you, with anyone over the world, it can be done so very easily. You can use your Skype, you can use Zoom, you can use your WhatsApp and things like that. And if you are using, for example, if you are using public Wi-Fi, then it can be pretty much free, right? That's why it's called technology affordance. And what makes technology affordance is, again, reprogrammability and data homogenization. This is the very core of digital technology. So I hope that I don't make you confused, but please keep in mind about these two fundamental properties. We will come back to this later on. But please remember that this is the very core of the digital technology, so don't forget about this. Okay, now your question is, where does AI fit in? So as I said before, we are now experiencing, or we are now having luxury of very fast computing power, very affordable computing power, so we can run many things. We can develop animation, we can develop complex computational algorithm, we can make anything. So with that, basically we are exploiting our device. We can use our computer, we can use our mobile phone, we can use any sensor, we can use any, for example, CCTV or things like that to gather information. And those data or those information can be in different format. For example, you may have some documents, you may have some videos recording, you may have some emails, you may have some table or chart or things like that, and you put them all together in one database. And from that database, again, we convert everything using data homogenization principle, right? Whatever format that you have here, it will be converted into binary codes. It will be put together in the storage or in the database, and then we will use the von Neumann architecture to process those kind of information, those kind of data according whatever we want. So we can use AI for analyzing data, for making prediction. If you want to predict whether the stock market will goes up or goes down tomorrow, and you prepare accordingly and things like that. And we can use AI for recognizing speech and image. We can train AI to self-develop themselves. We can use AI to help us in making decisions, especially if we are dealing with complex problems. And then the AI itself can be very different, because we can use AI for many different purposes. We can use it for machine learning, we can use it for natural language processing, we can use it for speech, we can use it for expert system, we can use it for planning, scheduling, optimization, especially with modern manufacturing, with computer integrated manufacturing. We can use AI for robotics, we can use AI for vision. So many different applications of AI, many different purpose of AI, but again, those kind of purpose, those kind of function, or those kind of technology still relies on two basic principles: data homogenization and reprogrammability, binary codes, and von Neumann architecture. Okay. Any questions? Anything, please? No? So far, so good? Okay. Okay. Does anyone knows about this movie? I know you watch a lot of Korean drama. Most of my students are watching Korean drama. This is not Korean drama. Does anyone knows about this movie? Anyone?
Alan Turing.
Alan Turing? Do you know the title of this movie?
The Imitation Game.
The Imitation Game, right. So, thank you. You are correct. This is The Imitation Game. And the story is actually about the First World War, and the British government is trying to break the code that is being used by German Nazi at that time. So Alan Turing, which is a mathematician, is being called to lead this project. So in 1950s, after the Second World War, after the war is over, Alan Turing wrote a paper, a very interesting paper, And then in that paper, he says something like the imitation game. So the imitation game was actually taken from his paper. So many people consider this paper as the ancestor or the great-grandfather, the great-grandmother of AI. Okay, many people considers that this paper or this guy, the Alan Turing guy, is the ancestor of AI, the great-grandfather, the great-grandmother of AI. And the paper is interesting because if you watch the movie, there is a scene that he was taken to the police station or a room, but it looks like a police station. And the officer asked him something, and he said, "So tell me, am I a machine or am I a person?" There is there is what we call Turing test from his name, Alan Turing. That is called a Turing test. So basically, Turing test is a test to see whether people can detect if they are talking to humans or talking to computers or talking to machines. If you cannot detect detect, or if you cannot differentiate between human or computer, then essentially we can say that the machine has passed the Turing test. Okay. So in 2014, BBC made a report about this. So there was an event in, I think, at the University of Reading in the UK. There was a machine called Eugene Gossman, if I remember correctly, Eugene Gossman. Eventually, they did Turing test, and we cannot distinguish whether this response comes from machine or comes from human, because there is the response is very, very similar. So the Turing test has been passed has been broken in 2014. So what I want to say is that have you read the article that I gave you? The article says that nowadays, if we want to write a song, we are no longer take your guitar or take your piano and then write notes and connect with your synthesizer, and then you go to the studio and then you take a sample of your music and things like that. No, it's not like that. If nowadays, if you want to write a song, you just open up your laptop, you just open up your computers, and then you put your variables, you put your input, you put your styles and things like that, and let the computer generate the music, generate the tones, generate the melody for you. After that, you can maybe you can add some styles, maybe you can increase the tempo or lower the tempo and things like that. But essentially, today's AI is very close to us, and AI is replacing or starting to replace musician, because as I said before, our machine nowadays has already broke the Turing test, has already passed the Turing test, so we can no longer differentiate, or we can no longer be able to distinguish whether the response was coming from machine or whether this response coming from robot or from humans. The same happens with the music. We can no longer be able to differentiate whether the music comes from songwriter, coming from musician, or coming from computers, coming from AI. And I believe that this kind of phenomena will also happens in different field. So AI will replace, like, probably it will replace doctors, it will replace physicians, because they can diagnose better compared to human. AI probably will replace accountants or financial analysts because they can analyze lots of data, lots of numbers very quickly compared to us human. And then maybe eventually AI will replace teachers, AI will replace lecturers, who knows? Because they can monitor your progress, they can give you a personalized feedback and things like that, which a human being probably not be able to do so. So if we come back to this Turing test, it seems that the technology nowadays has been able to pass the Turing test because we can no longer differentiate whether, let's say, you read some text in foreign language, you go to Google Translate to help you translate the text in your native language. Google Translate nowadays is becoming much better compared to 5 years ago or 10 years ago. And now we are starting to realize that it is very difficult to distinguish whether the translation coming from human, coming from expert in that language, or whether those translation coming from Google Translate, because the technology is already moving very fast. The same thing happens with, for example, if you create or if you write a song or if you recognize something, for example, in some place like in airport and in the immigration center, for example, they are using face recognition device, so they will recognize whether you are allowed to enter the country or not permitted to enter the country, for example. They can do it faster compared to a manual check by human. So if you want to develop anything, if you want to develop AI, if you want to develop some application based on AI, make sure that you can pass the Turing test. Make sure that your products, make sure that your technology can pass the Turing test. Make sure that your customer cannot distinguish whether the response comes from human or whether the response comes from computers. Okay? Make sure that you pass the Turing test. Otherwise, we cannot say that your AI application is successful. Any comments or questions? Am I talking too fast? No? Okay, good. Now, no questions? If you want to ask something, please don't hesitate to raise your hand, or if you are shy, you can write comments on the chat box and I will come back to that, okay? Now, let's move on to let's come back to the reprogrammability and homogenization, data homogenization. So by combining data homogenization and reprogrammability, we will end up into what we call convergence and generativity. What is convergence? What is generativity? Let's look at them one by one. Okay, generativity is basically about brings previously separate user experience. So back in 1990s or early 2000, if you want to watch football match, you have to turn on your TV. If you want to access the internet, you have to turn on your computers. If you want to call your friends or your family, you have to take your mobile phone and call them. But today, this kind of separate user experience was bringing together into one device. So if you have, for example, if you have smart TV, you can use it to watch a football match. You can use it for entertainment, to watch movies, to watch Korean drama. You can use it to access internet. You can use it to text your friend or your family and things like that. So With convergence, we can combine many different devices, many different tools into one place. And then convergence will also combine non-digital physical artifact with digital artifact. So for example, we can combine, for example, if we can combine watch with IoT or with sensors or with microchip, so that it can gives you an information about your location, about the direction if you want to go to one particular place, or if you want to, maybe you need an information regarding your medical condition, like your heart rate, or maybe your how many steps that you have taken, how many kilometers, or how long the distance have you covered, and things like that. So by combining physical artifacts with digital artifact, we can come up with smart technology, with smart product, like smartwatch, smart phone, smart cars, smart fridge, smart everything. Okay, and then it can also brings together previously separate industries like Skype. How do we categorize Skype? Is it a technology company, or is it telecommunication company? It is quite difficult because Skype is operating across different industries, across different sectors. The same thing is also similar with Netflix. Is it a media company, or is it a technology company, or is it maybe a kind of content developer company, or things like that? It is very difficult for us to categorize because digital business is now operating across different sectors, across different industries. So I'll give you a kind of illustration. Excuse me. So very quickly, if you take a look at Apple, back in 1990s or even 1980s, we know Apple as a computer manufacturer, but today most of the income was coming from iPhone and iTunes. It's about 62% of Apple's revenue was coming from iPhone or iTunes. And then the computer itself, the Mac itself, which previously becoming the core capabilities or core competence of Apple, is only contributing about 10%. So you see the convergence has changed many things in the industries. And also take a look at the Apple Pay, because the service here is growing very fast. Apple is now, it seems that the company is now moving to the mobile financing, mobile payment, and things like that. Let's compare it with Facebook. Okay, Facebook, we know the company is currently the market leader for social networking websites, and interestingly, almost 100% of the revenue coming from Facebook ads. One more thing that we have to really pay attention to, or maybe careful about this, is that the revenue per user is $35 compared to Netflix, which is only $30. Remember that Netflix is a subscription service. You have to pay for the service. It just gives you $30 per user. But Facebook, which is free, can generate revenue $35 per user. It's scary, no? It means that you are now becoming the product. Now, compare it with Microsoft. Microsoft is quite diversified because they have Microsoft Office, about 25%. Microsoft Azure, the cloud service, is about 23%. The operating system itself is about 17%. And they have lots of things here like Xbox, and then Bing, and then Microsoft Surface, LinkedIn, and so on and so forth. So Microsoft in this case is quite diversified, like conglomerate business in back in 1990s, 1980s. Compare it with Amazon. Amazon began the company as a bookseller. Okay, they sell books online, but now they are moving towards online store. They sell everything from books, electronics, houseware products, and things like that. But interestingly, the revenue from other services is also growing. The revenue from third party is about 18%. Revenue from Amazon Web Service, which is their cloud services, is also increasing very quickly, 11%. They also have other services like Amazon Prime and things like that. So consequently, from this kind of convergence, we see lots of shift. We see lots of changes in the company itself. Apple, previously, we know Apple as a computer manufacturer. Now they are becoming an iPhone company. Facebook, it is not a startup company, it becomes advertising company. Google is not a startup business, it is not a technology company, but it is more like advertising company as well. Amazon is mostly a store, mostly a marketplace, and Microsoft is a little bit diversified. But the thing that I want to emphasize here is that you have to be very, very aware or very careful about your corporate strategy, because you need to understand what drives your revenue. Because in the digital economy, your revenue can come from many different sources. Okay, Apple, Facebook, Google, Amazon, Microsoft, all of them originally were technology company, but their revenue, their source of revenue can be very, very different. So what can we learn from this? If we want to develop a company, if we want to develop some technology, we have to be very, very careful. We have to be very conscious about where our revenue will be coming from. And this can be quite interesting, because if you start your coffee shop, let's say, mostly your revenue will comes from selling coffee, right? But in technology company, you can earn your revenue from many other from many different sources. It can comes from your products, it can comes from your service, it can comes from advertising, it can comes from commission, maybe it can comes from marketplace. Many different options, many different probabilities, but we have to understand what drives our firm revenue, because in the digital economy, the possibility to earn revenue can be quite diverse. Okay, now the second thing is called generativity. So generativity means that we procrastinate binding of form and function. It's a little bit complicated. I know some of you probably quite confused, but I'll come back to this later on. Essentially, with procrastinated binding of form and function, we cannot see the finished product immediately. Because let's say you buy a new iPhone, right? Your iPhone is not your final product. Why? Because you can update the software, you can install new application, you can install new themes, you can install new games, you can even develop your own application on your iPhone. So the final product, or the procrastinated binding, the binding of form and function is being procrastinated. Secondly, it will manifest in the wakes of innovation, like I mentioned before. With 3D technology, it then being implemented in design and architecture form. It then being implemented in the construction project. The 3D printing itself is then being implemented in the manufacturing companies, because the contractor can see very clearly where is the the installation of your pipeline or your water installation and things like that. You can also use 3D printing to sell the properties to your customers as well. So by doing one thing, it will encourage other companies to do another innovation based on what you have been done. And then another thing that is also important here is that your innovation will leave unprecedented volume of digital trace that we call derivative innovation, right? Derivative innovation is very interesting because let's say I have a shoes and I want to put a microchip over there. From that innovation, we can generate lots of data, not only the data about your exercise, not only the data about your distance covered, your route, your medical information and things like that. But if you put your jogging information onto, for example, into your social media account, on your Strava and things like that, it will generate a lot more data, a lot more information that can be used by the company to create a service for you. This is what we usually never think about, is that those kind of innovation generates lots of derivative innovation. When we are using Google Maps, for example, Google will generate lots of derivative innovation from our route, from our movement from point A to point B. When we are using Google search engine, for example, they can generate information regarding what are the things that currently being wanted by the customers in one particular place or one particular region, for example. Now, this is an example that I mentioned earlier, just a moment ago. Let's say I have a shoes, I can put a microchip over there, and I know this is a little bit ugly. Let's say that this is just a prototype, but if you develop it in your let's say Adidas or Nike develop this kind of shoes, it can be it can look much better than this, but the principle is the same. You put your sensor, you put your microchip, you put it on your shoes, and then from there you can generate lots of information. How many distance, how many steps that you have taken, how many energy that you have consumed, and the speed that you generate from your activities, and the contact time from your foot to the surface and things like that. And from there, we can generate lots of derivative innovation that can be used to, for example, if you want to develop better shoes or faster shoes and things like that. Those kind of information is very, very important and very beneficial. Any comments or question? No? Anything? It's already an injury time. Apologies for this, but do you mind if I continue for about 5 or 10 minutes to finish the slides? Okay. That I want to emphasize here is that, let me skip this. This is basically a new technology developed by NVIDIA to help you generate your face or generate your voice, so that the communication through the internet, for example, through a Zoom connection like this, is going to be better or smoother, just like the face-to-face conversation, as if I am in front of you. But it also generates lots of criticism because it raises potential problems. We can use it for deepfake technology. We can use it to, for example, we can change the face with some political figures or some public figure that is very important, and to say something, let's say some political message or things like that, which is not true. So even though the technology can be beneficial for us, the potential or the danger of the technology is also apparent. Now, from generativity and convergence, the consequences of those two will result in one, the emergence of digital platform. We will come back to this in the next session, but essentially, most of the companies are now becoming a digital platform. Apple is now digital platform, Facebook, Google, Microsoft, all of them are now becoming a digital platform. But the structure of the platform is quite different. We will talk about this in the next session. Secondly, we see lots of distributed innovation. So innovation nowadays, when we are talking about digital innovation, it will always be involving different companies, different industries, different organizations. It will also increase the heterogeneity of knowledge, because the knowledge cannot be can be acquired not only from inside the companies, but also from outside of the companies as well. And consequently, we have to be very careful here, because we have to be able to organize those kind of different knowledge, different sources. And interestingly, if we want to be innovative, we also have to require others. We have to ask other companies to be innovative as well. That's why companies like Google or Apple, they develop their API or application programming interface and SDK, software development kit, so that developers can build their own application to be submitted to Google or to Apple. And then it will result in changes or convergence in industrial structure. It will also, if we are not very careful about this, it will also introduce new risks or unintended consequences. This is what I said before. The innovation itself will change. Initially, Google started the company as a search engine companies, but along the way, they develop their media and advertising division. They also develop their consumer electronic division. They also develop their cloud services, their AI services. They also invest in healthcare and investment, and also transportation and logistics, and so on and so forth. So from one innovation, it will generate the waves of innovation that will also affect the structure of the firm, and generativity and convergence will result in combinatorial innovation, which is combining different modules with digital capabilities. Like what I said before, shoes, we have running shoes with a microchip, with a sensor and things like that, or with a Facebook API, and so on and so forth. So consequently, it is important for a company to develop their own platform, to build up their platform, and learn how to carefully deal with fault lines. Because if we are not very careful about this, it will result in systemic risk. It will result in unintended consequences. Now, this is an example of combinatorial innovation. If you look at there is a combination of, for example, combination of Internet of Things with logistic internet, or a combination of cloud technology with robotics, or a combination of blockchain with smart cities. So essentially, there is nothing that is completely new, but there is a new combination of different existing technologies. If you are very creative in combining this technology, combining different actors, different firms, different organizations, you can come up with something that is going to be successful in the market. And finally, the key takeaways from my presentation this session is that first, the logic of digital innovation is very different compared to non-digital innovation because of the reprogrammability, because of the data homogenization and things like that. And then by understanding the foundation of digital innovation, it will help you to curate your digital strategies. You will know how to acquire the necessary knowledge. You will know how to establish your network, your ecosystem. You will know how to build a relationship with other companies from different sectors, from different industries. And you will know how to keep ahead of your competitors. And finally, by understanding this kind of things, you will be able to combine different actors, different platforms, different services, different technology to accelerate your innovation. Because again, innovation in the digital world is no longer be done by yourself, by your own company, but it will require many different actors, many different parties with lots of different interests and purpose and motives. So I think that's all. If you have any question, please don't be hesitate to ask anything. I hope this is not too much. I hope it can gives you a kind of overview about digital innovation and how you can develop your digital strategies along the way. Questions, please. No questions? Okay, if you have no questions, then I'll give you one question to ponder, to think about tonight or tomorrow. Is digital innovation essentially about digitization, commodification, and surveillance? So let's say you want to develop a business, you want to start your own business based on digital innovation, based on digital technology. Will you do the digitization, commodification, and surveillance and make money from that? Think about it, because by thinking about those three different things, it can help you to understand the complexities, the dynamics of the digital innovation. Okay. Finally, these are the key references that I'm using in this presentation. If you are interested in some of what I said before, or if you are curious about some of those things that I presented earlier, please go to this paper, and I will upload the slides. And thank you very much for your attention. Thank you very much for coming in this session. I look forward to see you next Wednesday. Okay? Bye.
Thank you, Professor.
Thank you, Professor.
Thank you, Professor.
Thank you.
Bye, Professor.
Thank you, sir.